Today, I want to talk about if we have a positive number, right, a real number, raised to the power of I, how can we graph that? So it's actually pretty easy. Well, what we really are going to rely on, though, is Euler's formula. Now, what is that? That says e to the power of I theta equals cosine theta plus I sine theta. Okay? So we're really going to be relying on that. And let's practice with 8 raised to the power of I. So we are going to start with 8 to the power of I. Now, we want to put this into the form whereas e raised to some power. But how can we do that? Well, we can actually rely on natural logarithms. So we can say that this is equal to e to the power of the natural log of 8 to the power of I, right? And we can say this just because of basic logarithm properties, right? We could cancel out the e and the natural log and just be left with 8 to the power of I. So we haven't changed the value at all. Then, let's remember through logarithm properties, if we have log x to the power of y, that is equal to y times log x. So we can change this to e I times the natural log of 8, right? So we can take out the I of the natural logarithm. So we actually now have our theta value, and that's going to be the natural log of 8. So we can convert this to cosine natural log of 8 plus I sine natural log of 8. All right, now we want to actually evaluate what the natural log of 8 is. So I'm going to use a calculator, right? So we have, maybe you can see it, I don't know, natural log of 8, that equals 2.07, we'll just say 2.08 in this case. So then we can say this is cosine of 2.8, what did I say? 2.08 plus I sine of 2.08, right? So now we actually have it in polar form, but we still want to graph it. So now we want to convert it to rectangular form. So how should we do this? Well, first of all, these measurements, right? This is the angle. Let's just remember that if we have some plane, right, and we have a line, right, whatever this theta angle is, that is equal to this angle there. But currently, this angle is in radians. I want to convert it to degrees just because I think it'll make it a little bit easier for us to work with. So let's remember that the conversion formula for radians to degrees is whatever the number of radians are times 180 divided by pi. So so 2.08 radians equals, let's get out our calculators and let's take 2.08 and multiply it by 180 over pi. All right, you can see that's what I have done there. Let's press enter and we get 119. All right, so let's write that down real quick. 119 point, we'll just say 18. Right, now we just reviewed what that means. Right, so now what I want to do is draw out a triangle. So we're going to draw this out. And we actually already know what the hypotenuse of this triangle is going to be. Because we're trying to think about, we have the angle and we have the hypotenuse of our coordinate, and we're trying to figure out how much it's moved along the x-axis and how much it's moved along the y-axis, right? So that's what the triangle we're drawing out here. So this is a 90-degree triangle, right angle triangle. So we know the hypotenuse is actually equal to 1, right? And let's remember, that's because in this case, if we have some e to the I times theta, right? If we have a longer than 1 hypotenuse, that number will come before e. We'll be multiplying e times that. But in this case, it's just 1. And we can figure out what this angle is right there, because we already know what, if we, once again, if we draw out the complex plane, right? Let's say this is real, and this is imaginary. Right? We already know that what this angle is right here. We know that this is 119.8. So what we can do is we can take 180, right? Because this entire line is 180 degrees. And we can subtract 119.18, right? So you can see that's what I've done here. We'll press enter. And we get that this is 60.82 degrees. So 60.82. All right, and we don't need this angle, all right, because now what we're going to do is we're just going to use trig identities. We're going to use sine and cosine to figure out these two sides right here. So we can just say, let's remember, SOHCAHTOA, right? SOHCAHTOA, right? We're not going to be working with tan in this case, right? Sine equals opposite over hypotenuse, right? So we already know the angle, so we can say sine of 60, let me put the parentheses, 60.82 equals, well, opposite is what we're trying to figure out, x over hypotenuse. Hypotenuse is 1, right? So the 1 can actually cancel out, and we can just say that x equals sine of 60.82, right? So let's take our calculator out once again. And so 60.82, right? We do that, and we get 0.87. So this is 0.87, all right? Then we want to find what this is down here, and we're going to use the cosine function for that. So remember, cosine is adjacent over hypotenuse. Now, we already know that the hypotenuse is 1, so that will cancel out, right? And we already know the angle. So what we can do is we can just erase this sine bit right here and change this to cosine, right? So then let's take out our calculator once again. Let's do cosine of 60.82, right? Oh, I almost put a 90. Let's clear that. Cosine of 60.82, right? You can see that's what I'm putting in. Then we get 0.4, well, let's say 0.49. Okay, so now we know that this coordinate, right, is 0.8, actually, sorry, I'm doing y before x. We know that this coordinate is 0.49, comma, 0.87. So if you're better at drawing, I recommend you should try to graph this yourself. Now, I also want to leave it up to you guys. You guys should try to graph out what 15 to the power of I is. Try graphing that one out and see if you can do it. Right? I think you can. I think you got it. Thank you so much for watching my video. Let me know if I said anything incorrect, if you have anything additional to add. Have a great day.